Hello everyone, welcome to In 5 Minutes. In this video clip, we will discuss one special type of filter which is called notch filter. A notch filter is a filter that contains one or more number of deep notches or ideally perfect nulls in its frequency response characteristic. Perfect null is nothing but a magnitude becoming zero. So basically notch filters, when we draw its frequency characteristic, especially the magnitude spectrum, we will see certain frequencies at which the magnitude will come down to zero. So for example, I've drawn one frequency spectrum of a notch filter. You can see in the magnitude response that we have on the screen right now, which is drawn for the range of omega from 0 to pi, which is one side of omega. Omega otherwise varies from minus pi to plus pi, but for all the practical systems, it is enough to draw the frequency response from 0 to pi because of the symmetry. So you can see the magnitude response becomes 0 at omega 0 and omega 1. So this type of frequency response will correspond to a notch filter. Notch filters are useful in many applications where specific frequency components must be eliminated. For example, instrumentation and recording systems require that the power line frequency of 60 Hz or 50 Hz and its harmonics be eliminated. So in many communication systems or instrumentation systems, as we just now mentioned, the power line frequency, which can be either 50 Hz or 60 Hz, it enters into the circuit and mixes up with the information signal. Now in such a case, we want to remove this frequency from the signal, and in that case we can use a notch filter. If we also want to remove its harmonic, then we can have multiple notches in the magnitude response. So for example, if I want to remove 50 Hz power line frequency, then corresponding digital frequency omega naught will be set equivalent to analog frequency of 50 Hz. Omega 1 can be the first harmonic of 50 Hz, which will be nothing but 100 Hz, and so on. So now let us try to understand what kind of transfer function a notch filter will have. We all know that to create a null in the frequency response of a filter at certain frequency, let's say omega naught, we must introduce a pair of complex conjugate zeros on the unit circle at an angle of omega naught. So that's all we have to do. So let us consider null at omega equal to omega naught. So I'm just introducing single null. We can have multiple nulls also, but we are right now introducing single null. So null at omega equal to omega 0 will require us to add two complex zeros on the unit circle, and hence magnitude is 1 e raised to j. Frequency will be omega naught. Complex zeros will be 1 at omega naught, 1 at minus omega naught. So the system function becomes, if I know two zeros, then I can write h of z as b naught will be some constant. I can write 1 minus e raised to j omega naught, which is my first zero, into z inverse, into 1 minus e raised to minus j omega naught z inverse. This is my second zero at minus omega naught. So first zero at plus j omega naught, second zero at minus j omega naught. Ideally it should be r e raised to j omega. R is equal to 1 because both the zeros are placed on the unit circle. If I expand this, I will get b naught into 1 minus e raised to j omega naught z inverse minus e raised to minus j omega naught z inverse. And finally, when I multiply the second term in both the brackets, minus minus plus, e raised to j omega naught into e raised to minus j omega naught will become e raised to 0, which will be 1. Z inverse into z inverse will give me z raised to minus 2. This can be further written as b naught into 1 minus. If I take minus z inverse outside, then e raised to j omega naught plus e raised to minus j omega naught will be nothing but 2 cos omega naught plus z raised to minus 2. So that's my system function of a notch filter. So this very simple filter will have single notch, and that single notch will be at omega naught. If you want to introduce notch at omega 1, that means perfect null at omega 1 also, then I should consider one more pair of zeros, this time at plus minus omega 1.